Hello, everyone. Is everyone able to hear me? Please use the questions window to respond. Great. All right. So, welcome to our introductory webinar on Big Data and Hadoop. My name is Anjana, and I'm part of the team here at No Big Data. I'll quickly be taking you through what to expect of this session. Please make use of this time to introduce yourselves as well. So the first half of the session will focus on understanding big data and why it is relevant in today's world, followed by a 10-minute break, and then we will move on to Hadoop architecture. Those making notes can sit back and relax. We will share this presentation and recording with everyone here. No Big Data stands out for having instructors who encourage questioning. So please keep those questions coming. Since this is an introductory session, we have a lot of attendees, which is why everyone is muted. So our instructor will be reading out a question for everyone's benefit before answering it. The chat window is going to be the primary mode of communication today. You can ask your questions by typing it in that questions window that you see. So to get better answers from the instructor, please keep your messages short, and it'd be great if you could avoid chat language. As everyone's probably already aware, this is session 1 of our 11-part course for Big Data and Hadoop, but on its own, it will suffice as an introduction to big data technologies. For those who will be joining us for the rest of the course from the next session will have fewer attendees, and we will be using a different, a more interactive tool for all forthcoming sessions. So before introducing you to Big Data and Hadoop, let me introduce you to No Big Data. Our primary focus is online trainings relating to big data and data sciences. We have instructors who are industry experts. You will soon find out for yourselves how true that is during this session. As part of the course, we provide access to Cloud Labs, which is a cluster that you can use to play around with whatever you learn during the classes. This feature is unique to big data, to know big data, and gives you a real feel of how things work at organizations that use big data technologies. Course takers are also given lifetime access to our learning management system, which will include all the presentations, recordings, assignments, and project work. At the end of the course, you will get a real-life project to complete, and will receive a social media compatible certificate that you can post on LinkedIn, Facebook, etc. So you will also have 24/7 online support and be part of our alumni group, which will keep you posted on new job opportunities and help you stay updated and connected. So let us move on to today's session. Our instructor today is Sandeep Giri. I will let him introduce himself and take it over from here. Have a great session.
All right, so hello everyone. Are you able to hear me clearly? I'm Sandeep Giri. I'll be the instructor for this course. Are you able to hear me clearly? All right. So please feel free to introduce yourself through the questions window, and here is my introduction. Great. So everybody is able to hear me clearly. Great. So I myself, Sandeep Giri, I did my graduation from IIT in 2002, and afterwards I joined a company called DE Shaw, where we were building big data systems even before the term was coined, because DE Shaw is well known for churning large amount of data, and we had a cluster of 10,000 node in 2002. And after D Shaw, I founded a company called Tbits Global. It's an enterprise document management system and uh, is in itself quite a good product. After T-Bits Global, I joined a company called InMobi, where I built their recommendation engine after churning around 200 terabytes of logs. After InMobi, I joined Amazon. At Amazon, we built high throughput systems and for their Amazon.com website, where for their image optimization, and that engine is used at many places other than the detail page. All right. So that's about me, and let me just go through. So today we are going to discuss big data, and then we'll get into the details of Hadoop. If time permits, then we'll move to MapReduce. And okay, all right. So let me introduce the candidates who have joined the session. We have Mankia from Bangalore. We have Anuj Puram working as a software engineer and is working on Java in Austin, USA. And yes, we have Abhishek Jaitley. He has worked in Cognizant for 1.5 years and is going to US for my higher studies and is passionate about learning technology and is planning his career in big data. Great. Great to know you, Abhishek. We have Mandar. Mandar is a database uh, SME, and SME, if I understand correctly, is subject matter expert, or what does SME stand for? Or senior member? Uh, okay, and is an architect in DB2. All right. We have Savita. Savita has done her BE in computer science, having 11 years of IT industry experience, and primarily into mainframe for 9 years. Great. And 2 years in testing. Great to know you, Savita. And we have Kirupa. Kirupa is currently working in Emphasis Limited as a test engineer. All right, from Pune. All right, so okay. So Mandar's question is, if you can just give me a brief about how big data will help me from database perspective. So So, in brief, when the normal databases are not able to handle the data, that's where the tools to handle big data come into play. So definitely this will complement your knowledge about handling the data. And we have Shyam working in HP as a data engineer and is looking forward to become data scientist. Great. Great to know you, Shyam. And we have Akshay. Akshay is working with Syntai. And we have Hariharan, who is a student in masters in computer science. Great. We have Srisha from Bangalore working with Meridian. Hi Srisha, and Srisha has experience in JavaScript, jQuery, and full front end development. All right. So we have Arvind. Arvind, are you able to hear me now? All right. We have Vignesh who is working as a software development engineer with Flipkart. Great, Vignesh. Great to know you. And we have okay. Shrisha has finished her MTech in Triple IT Bangalore. Great. And we have Jay Parik is pursuing BTech 7th Sem. It's too early for me to learn big data. No, it's not too early for you, Jay. Okay, you are just yeah. All right. So Arvind is working in Tier 2 from Pune. Great, great to know you all. And so should we start now? Let's just start. We have Namrata, who is working with Accenture and in AngularJS. Great. All right, so we move on. All right, so before we start getting into the bigger discussion of big data, let me understand, what do you understand by big data? So what is your definition? And then we will continue with our understanding. Okay? So let me just close a couple of windows which are disturbing here. All right, so what exactly is your understanding of big data? Feel free to answer with whatever is your understanding so far. Anu says it's a way of handling large amount of data. Yes, and Spurti says unstructured data is big data. All right. Shisha says huge set of data. Jparak says the data that is too large to handle. Sham says big data, according to me, is a term coined for large data sets, basically the in terms of volume, velocity, and veracity related to big data. Savita says big data is extremely large, complex data. Abhishek says big data basically too large to handle in terms of traditional means. Okay, that have been using till now, using the techniques. Okay. Satish says that for storing and processing large amounts of data. Great. Great. Arvind says data in various format unable to process using a single machine. Great. Great, Arvind. Mark says the system and tools used to manage massive amounts of data not usually manageable using standard RDBMS. Great. Hariharan says multi-node parallel data processing. All right. So Praful says high volume, different type and high speed. All right. So Mankya says combination of structured and unstructured data. Gopi says handling different set of formats. And Manda says it's conventional RDMS. Great. So a great set of answers. So yes. So here is the definition which we will stick to. Big data means simply the data of very big size that you cannot process using usual tools. Usual tools means such as your normal file system, normal databases, okay? And for handling such kind of data, you generally need distributed architecture. Okay, so in this full course, all the tools, around 14 tools which are going to discuss, all of those tools are going to be of distributed architecture. And this data, as in the traditional terms, it could be structured or unstructured. So in our definition of big data, we will stick to the term distributed architecture. Okay, and what does it mean by distributed architecture? You can understand from here. And distributed architecture simply means group of networked computers which interact with each other to achieve a common goal. Okay, and this can be easily distinguished from parallel computing, because in parallel computing you have multiple processors but a single memory, and using this memory the processors coordinate with each other to attempt or to finish a task. Okay, to accomplish a task the various processors use the memory, while in case of distributed it's the computers which are connected to each other. Okay, so we take the usual kind of servers, we connect them into network, and we install these new generation of big data tools, and and we get our work done. That is distributed computing. So for example, in this course, all the tools that we are going to deal with, starting with HDFS, and then going forward for Yarn, MapReduce, Hive, HBase, Pig, and NoSQLs, then Zookeeper, then Spark, Scoop, Flume, Mahout. Each of those tools are distributed in nature. Okay, so this course will be this full course of around 11 sessions will have a full details about these various tools required for distributed computing in today's time. All right, so is everybody clear about distributed computing? Great, great. So So again, big data is nothing but data of very big size that you cannot process with usual tools, or you cannot process with single computer. You inevitably require distributed architecture, tools that run on multiple computers. Okay. So effectively, big data is is huge, or by the way, either the volume is too high or velocity is too high, by virtue of which you you require you require the you require the distributed architecture, meaning multiple computers to solve your problem. Now another term that we will be using is structured and unstructured data. All right. So when we talk about various kinds of data, we generally distinguish the data which is structured from unstructured in the following manner. So structured data is, in a structured data, we know what exactly are the fields in our data, as well as what are the data types of those fields. All right. And in case of semi-structured data, we know what are the fields, but we do not know what are the fields data type. So example of structured data is a Excel sheet or relational database, where we know in a relational database, in the table, we know clearly that our table has these fields or these columns, and these are the data type of each columns, right? We know clearly. And in case of semi-structured data, we know what are the various fields in our input data, but we do not know what are their data types. For example, if I give you a CSV file, comma separated file, okay, a comma separated file contains many lines, and each line, the value the values are separated by comma. Okay. Now each individual value in CSV file, I do not know the data type of. Okay. Although I'm quite clear that this is my each record, and these are the fields, but I do not know the data type of each individual fields. And that is an example of semi-structured data, meaning the data in which I know the fields, but I do not know the data type of the fields. Next is the unstructured data. In case of unstructured data, I neither know the fields in the input, nor I know the data type of the fields. Okay. For example, the logs generated by your web server. To understand or to separate the fields, I need to run a process called parsing the data. Parsing the data means we programmatically figure out that from this point to this point we have this field, from this point to this point we have that field, and this field has got that data type, and so on. Okay. So the process of converting an unstructured data into structured data is called generally parsing the data. Okay. And it's a part of ETL process. So in an unstructured data, We neither know what are the fields and nor we know the data types. All right. So when we deal with big data could be in any of the formats. Correct. So Mandar's question is field, you mean column names? Yes, that's how you can interpret. But that's not only column names. Imagine that you have an XML file. Now XML is a little tricky matter. Some XMLs provide the data type of each field clearly, while some XMLs do not provide the data type of the various values. Okay, so XML file could be unstructured and could be an unstructured based on the data type provided. Similarly, but for case of JSON format, we generally have a very clear idea whether a particular value is a string or is a integer or is a big object. So JSON object or JSON format is generally considered structured data. All right, great. Now carrying on. All right, so when we talked about what is big data, we said we talked about distributed computing, as in the data so big that cannot be handled by a single computer or by our traditional systems, and we require distributed system. Okay, meaning we require multiple computers to do our job. Now there could be there are basically three common attributes of data. Data could be called big because the size of the data is too big. Second, data could be called big data because the velocity of the data is too high. Okay, or data could be called big because of the variety of the data. Okay, now let me give you one example each. Now imagine in case of Facebook, the the data they have accumulated, the data which is at the rest will be too huge. Okay, so to handle that data you would require new set of tools. Okay, so that you can think of it as data at rest or the volume. every second every second, whenever the users are checking their phone, checking their website, opening the facebook.com on their browser, they are sending requests to Facebook. And because of this, there would be a humongous traffic going to Facebook continuously. And that is velocity. Number of requests going per second to Facebook. Similarly, in this session, what we are having now, the data which is being transferred to all the attendees simultaneously would be quite high. Okay, so to handle such kind of velocity, one system does not suffice, and therefore we need to load balance, meaning we need to have multiple systems serving the users their feed. Okay, and to build such kind of system, you need to have understanding of distributed computing. Similarly, the data could be big because of the kind of data we are going to handle or the kind of problem we have at hand. Whether the data is complex or the kind of problem are we solving is complex. In both the cases, we call that the variety of the data is causing our data to become big data. Imagine this. You have got Google Maps, okay, or you have got normal maps for a country. The data would be in maybe hundreds of GBs, okay, which you can easily store on one machine. Similarly, there would be no velocity, okay, but if you have to find the distance from one point to another in this map, it will take a tremendous amount of efforts. Okay, and to give the answer in a reasonable amount of time, to give the answer that to find the path from one point to another in a reasonable amount of time, you would require a system that can solve this problem using multitude of computers. Okay, so this is where the variety comes into play. So Bhaskar's question is, what about video data? Which type it is? Generally, we consider the video data as unstructured data. Okay. Now there is the fourth data type, which is veracity. Now this veracity is nothing but the data due to confusion. So you might have multiple data sets representing the same data, and since you are not clear about which data to keep and which data to delete, okay, you might need to process all multiple data sets, and so data due to confusion causes the big data. All right, is everybody clear about the veracity bit? So Mandar is saying, so now Facebook, YouTube already uses big data. Yes, Facebook, YouTube, Amazon, all of the people who are already have been handling the big data since 2000, since 2000s, for like 15 years now. They have built their system, or they are adopting Hadoop and other components. Okay. All right. So let me repeat the veracity bit. So Anuj's question is, so is it in doubt we store different data sets, or which leads to veracity? Okay, let me just repeat the veracity part. All right. So yeah. So let's take a good example. Say you decided to do analysis of your customers. Now there are multiple systems who have been keeping the information about the customers in your organization, and you get around 4 or 5 data sets. All right, and to reach to a conclusion that which data set is most complete, you will have to run some analysis, some tests, but till then you'll have to store and tackle all of the data sets, right? So you can clearly see that because of confusion, you will be storing all the data sets. Similarly, let's say, let's take another example. So let's say you are supposed to find out the temperatures, or the impact of temperatures on climate, on say on the produce of a country. Okay, or produce of a city. What is the impact of temperature? So you contact various agencies, and you get various format of data. First one says that they will give the data, they will give the data which is in the form of coordinates, xyz coordinates, xy coordinates, and the uh, and the and the temperature. Okay, and they say that their data accuracy will be, say, 50 meters. Now there'll be another company who says that they give the data only with respect to zip code. Then there is a third company which says that they will only give the data per hour, not per minute. Now you have got these 3 data sets. To understand which data set to keep and which data set to avoid, you will have to do analysis such as which data set can be reached from other data sets. So effectively figuring out of the 3 data sets which can be deleted, and can be kept. But to run such analysis, you will have to store all these three data sets, as well as you will have to churn all the three data sets, and hence causing it to big data. All right. Now we have got a good question from J. Parak. What about the time when there was no big data? There was Big data was not there. Okay. So the thing is that most of the companies keep on deleting the data all the time. Okay. First, they did not record the data. And second, they kept on deleting the data. Third, those companies like I was talking about DE Shaw, who really cared about data even in 2000s. Okay. So in 1990s, they had a cluster, because in 2002 we have worked on a cluster of 10,000 nodes. So even though big data was not a term, people had been handling the huge data. Okay, those who could build their own systems, they built their own systems, recorded huge data, and processed this huge data. But for those people, for others who could not build cheap systems, they thought that storing 1 gigabyte of 1 gigabyte of data is too costly, and therefore they kept on talking about the data value, and in order to maintain the money spent on the data, they kept on deleting the older data. Okay, so that was the older history about most of the companies. And all right, I hope I answered your question. All right, at Disha we built our own proprietary softwares to handle big data. So Savita's question is, in those cases when there was no big data, what tools or softwares used in organizations to handle large data prior to the big data emerged? So big data is just one term or industry. Okay, what has emerged is the tools and technologies, and these tools and technologies were there already in one form or the another, but not as seamless as they are today, and as useful as they are today. Okay, but before these tools were made public and made open source, the companies like Disha, which I've known personally, we had our own small tools, and we used to call it grid computing. Okay, we used to call it grid computing, and we had built our tool such that we can execute a program on a grid, and every programmer was supposed to keep in mind that every programmer was responsible for building the tool which can do the work parallelly on many computers. So so that was quite painful and quite error prone for the developers. All right. So I hope I answered your question, Savita. All right, just a quick teaser. Great. So how many bytes are there in petabyte? Just to check whether you are awake or not. And all right. So yes, quickly, the first answer. Correct. So it is 10 to the power, 10 to the power. Correct. Great. Thank you, Kalwa. Thank you. Thank you, Srisha. Thank you, Arvind. Thank you, Mandar. Thank you, Savita and Urs. Great. And yeah, you're correct. So yes, it's also 2 to the power 50. That is Urs. And All right, so this is a table which can help you remember various. Okay, so kilo, mega, giga, tera, peta, exa, zeta, iota. All right, and a byte here means 8-bit, and each is like a switch. Either it's 1 or 0, and effectively 8-bit can store 2 to the power 8, which is 256 states. All right. Now, we talked about big data and we talked about 1 petabyte. So, is 1 petabyte big data? And before you counter question me that what do we want to do with the 1 petabyte, let me say, let me tell you this. What I want to do is every day I want to count vowels in this 1 petabyte data. Every day I want to just count how many vowels are there in this 1 petabyte data. So my question is 1 petabyte big data with reference to the problem I'm trying to solve? So Bhaskara says that it's not a big data. And Srisha Abhishek say that it's big data. Arvind says that it will need so much processing. Hariharan says it's a big data. Great, great. All right. So we have only one answer. Okay. All right. All right. Now we have got. So Vignesh is saying that yes, loading the entire chunk into memory for checking vowels wouldn't be possible in a single system. So see, for checking vowels, we don't have to keep the whole data into a single memory. We just need to read it from one side to another. Okay. So Mark's question is, it depends. And on what factors does it depend, Mark? So my problem statement was that every evening I want to count vowels in this data. All right. So okay. So now let me answer it a different way. Satish's question is, do we use MapReduce job in Hadoop to solve this? Yes, we do use MapReduce job on a cluster to solve this. That's correct. All right, Anuj, just have a patience. I'll answer. All right. So now to understand why counting vowels is a difficult problem, we need to understand that it's not the processor or the RAM alone which become the bottleneck. It's also the disk input output. The rate at which you can read from disk may also become the bottleneck. And in case of if you have 1 petabyte data and you just have to read it, okay, you don't have to retain it in the memory. You just keep on reading and keep on ignoring the previous array, and you keep on reading all the data. Even in that, okay, just simple reading the data will, will be quite time consuming. Okay, so when you are reading 1 petabyte data, the IOs will become the bottleneck, and therefore it is going to be big data. Okay, now to understand why it takes so much time to just count vowels in 1 petabyte data. Let me ask you this. How much time do you think does it take to read 1 terabyte of data in a hard disk? Not the solid state drive, but in the hard disk. So how much time does it take to read data from 1 terabyte data from one hard disk? Or let me ask you the other way. You have got one hard disk containing 1 terabyte of movies and you want to copy those 1 terabyte movies into your own hard disk. Okay, how much time do you think it will take minimum? Just to read, not write. So Michael, this is so everybody is muted, and uh, to ask the questions you have to use the question window there, because there are many candidate in this class. All right. All right. So Arvind says at least a day. Santosh says 20 minutes. Shisha says 4 to 5 hours. It depends on the network, that is Savita. Great. Great. Mark says around at 10 hours. Jay says that it depends on number of tracks of the hard disk. Okay. And so yes. So Jay, could you be a little bit more I agree that it depends on number of tracks, RPM of a hard disk. In a usual scenario, how much time does it take? Sham says 3 hours. All right. Great. Great. So yes. So some of you are correct. So it takes around 6 hours on an average hard disk. But if you have a slower hard disk, it might take 10 hours or maybe 11 hours. Okay. Or 12 hours. So it's not, I mean, it will, rest will vary. So those who have answered 4 5 hours is also correct. There is no hard and fast. But the idea is to understand that just reading this data will take 6 hours. Now, if you have 1 petabyte data, it will take 6,000 hours, right? And I said that what do I want to do with 1 petabyte data is I just want to count the vowels. So it will take minimum of 6,000 hours to count the vowels in 1 petabyte data. And in these 6,000 hours, CPU and RAM and everything else will be fairly free. It will not take too much of effort because system will be mostly waiting for disk to finish reading, right? And also storing 1 petabyte data, going back to my question, this one, storing 1 petabyte data would also not be possible using a single computer. Okay, you'll have to use multitude of computers to store 1 petabyte data reliably, and therefore 1 petabyte data is definitely big data, because we cannot solve the problem of counting vowels or storing 1 petabyte data without involving multiple computers. All right. Now this is the graph which is quite popular. It just shows that the pace of the big data, or pace of the data at which it was started accumulated, suddenly became exponential in 2002. The rate at which the data is accumulating became really steep. So Hariharan's question is there any formal approach to calculate this time of 6 hours? There is no approach. It is a number, it's an empirical number which people have found while reading the data from the disk. It takes around 5 minutes to read 1 gigabyte data from normal hard disk. Okay. And solid state drives are around uh, 20 times faster than the normal hard drives. All right, that is Hariharan's question. All right, so yes, Now, why this evolution, this beginning of digital age started in 2002? Okay, the common reason is first the devices, second the connectivity. Okay, these are the two reasons which because of which the data started accumulating so fast, as shown in the previous chart, that in 2002 the digital storage became really high, and the by the end of 2007 we had 280 exabyte of digital data. Okay, which 280 exabyte means 3 3 followed by 20 zeros. All right, so why did it happen is because of first the hardware. The smartphones became cheaper, faster, and smaller. Like with any hardware manufacturer, every hardware manufacturer has these three objective in mind: cheaper, faster, and smaller. And that resulted in the smartphones. And a smartphone acts like a data generator. And at the same time, the connectivity became really high, meaning the we had Wi-Fi, we had 2G, and we have the connectivity in the form of Bluetooth and other means became viable, became really possible, and because of which the data we started generating a lot of data. And of course, when the hardware was available, the software also evolved, such as YouTube, Facebook, Twitter, Flickr, and whatnot came into play, which helped store and propagate the data of one user to another users. Okay, so these things combined together generated a lot of data. All right, now a quick question to all of you: which components out of these A to F, which components impact the speed of computing? A, CPU, B, memory, C, memory read speed, disk speed, disk size, network speed, and all of the above. So which components do you think impact the computing? Correct. So all of you are correct. All of these components impact the speed at which the computing is done. And keep this in mind, because I mean, the way we had been always taught that it's the Pentium processor which is making my system run faster, but that's not true. It's also RAM, it's also your network card, it's also the rate at which you are reading from disk. And if you do not believe me, just try replacing your hard drive with a solid state drive and expanding your RAM with a bigger RAM, to just doubling your RAM, and you will find your system really fast. So it's not a single component, it's other components also. All right. Yes, Damodaran says one other thing is OS. Of course, the software layer is also important, and uh, that's where we will focus on. But on hardware side, it's important to understand these are these are the four basic components that matter. Okay, although in a computer everything matters, but these are the four things which we need to pay more attention to. Okay, first and foremost is CPU. Okay, so but surprising thing is the CPU in most of the servers or most of the machines is fairly free. If you look at our cloud labs, it's the CPU which is fairly free. Okay, and mostly the bottleneck is RAM. Okay, bottleneck is RAM, or in case of data size, is the hard disk's read speed. So CPU, RAM speed and size, disk speed and size, and the network speed. So these are the components which which make our computing possible. And any of these components, at least one of these components will become the bottleneck when we are dealing with big data. At least one of the components will become the bottleneck when we deal with big data. Okay, and that's when we say that, okay, we are no longer able to increase the RAM size, or we are not able to make our disk reads faster, so let's add more computers to the network and get the work done using multitude of computers. Okay, so now examples of big data customers, this is something which everybody wanted to know. There are many examples as of today. Every now and then, I keep on seeing lots of people in lots of domains are utilizing these big data tools in order to solve their problems. Okay, there are many beautiful use cases that people are coming up with, and they are really able to solve the problem which they could not solve earlier. Okay, so for first and foremost is the recommendation engine. This was probably the first use case that was the most impactful in case of Amazon, in case of Netflix, and in case of few other systems. So recommendation could be in the form of that, uh, where this with this particular thing, or customer who bought this also bought this, or it could be in the form of, based on your past history, these are the movies you would like. And so this is the this is called recommendations. Now, generating recommendation using big data tools has become extremely simple. Okay, it's extremely simple. The main algorithm is available to everyone. It's just that this since since for generating recommendation, it's better to use big data. Why? Because the bigger the data, the better recommendation you will get. It's like saying the average rating of the movie will be reflecting better if you have bigger data. Similarly, if you have bigger data, then you will have more data points, right? So and the way recommendation works is finding the similar users in the data. So let's say there is a recommendation for movies. We will find out which users are similar to each other, and then we will give them recommendation to each other. So this way we can give a beautiful set of recommendation only if we have big big data to churn. If we have only few hundred ratings or few thousand ratings, it doesn't make sense. uh, if we have say millions of ratings by millions of people, then we'll have really strong recommendation. Okay, and that's why recommendation makes sense in case of big data. And that's the reason why Amazon is able to make lot of sales through giving recommendations either on the website or in the newsletter or in an update email. Okay, and the way recommendations are generated is is pretty straightforward in today's time. If you have a tool like Mahat, it will basically take the input in the form of which user, which movie, and how much they like it. And taking this input, Mahat will actually run a simple algorithm and give you the recommendation in this format. Okay, so algorithmically it's very straightforward, but converting your problem into this three column data set along with the ratings is something that would require a lot of work. That would require you the understanding of these big data technologies that we discuss in this session. Why, while the main algorithm of generating recommendation, that is Mahat will give you result easily. You don't have to program Mahat. All you have to do is present your data in this format. But as as opposed to the understanding. uh, Presenting this data into this format is actually challenging when your data is in terabytes. Okay, if you had to translate your data, normalize the data, and find out the rating, it will take a considerable amount of time. Okay, and that's where these big data tools come into play. All right, Spurti's question is big data taken forward from Google? So yes, the main is the whole story of big data actually started after Google launched couple of papers. Okay, so you are correct, Spurti. We'll talk about those parts when we discuss HDFS and MapReduce. All right. Okay. So is this clear to all of you? So you gave the result like this person liked this movie this much, and Mahat will take this data and give out the results like Kumar will like this particular movie and this much. So Mahat is doing the predictions for you based on this input data. All right. So your job uh, would be to present this data to Mahat in this format, three column format, and with the proper rating, which is out of 5. So, all right. So Damodaran says that does every organization has their own big data processing tools, or is there any standardized tools? Okay. So it all depends on which organization we are talking about, but most of the organizations are adopting to open source. Even at Amazon, we had opted for tools from open source and ignoring our internal tools at many point, because open source tools were were far more stable than our proprietary ones. Okay, so in the end, most of the organizations shift to the open source standard tools such as Hadoop and other Cassandra, MongoDB, and those tools. All right. Now, Savita's question is in future, is the technology leaning to substantial relational database with big data? Okay, so okay, let me repeat the question. In future, is the technology leaning to substitute relational database with big data, or those are two distinguished features serving different? So the second one, those are two distinct features serving different suite of functions. All right. We'll talk about this again when we talk about myths. Mandar's question is how big data tools such as Mahat would be different than data mining tools. Good question, Mandar. So again, the algorithm which Mahat is using is not something very new. Those two, the algorithms were already there in data mining tools, take R or others. The only thing Mahat did was it distributed the work. So when Mahat does the recommendation, it runs on top of Hadoop on thousands of computers and gives you recommendation in a reasonable amount of time. Take the case of R. If you have few GBs of data in input, the usual tools I'm talking about, and you have to generate the recommendations, it will generally lead to the memory overflow. The data reaches to few GBs and the R will get the memory overflow. But in case of Mahat, it's able to churn terabytes of data without a fuss, without any problem. All right, good question, Mandar. Now, Arvind's question is how do we conclude whether a particular customer needs big data or not? You generally have to see two things when we have to decide one particular problem requires big data or big data tools or not, is looking at the data do the back of the envelope computation the way we did in case of deciding whether 1 petabyte is big data or not, and understand what exactly are they trying to achieve. And then just based on a back of the envelope computation, you will be able to compute how much time will it take. Okay, how much time will it take for a particular data. Also, when you are trying to decide that, when you're trying to understand a problem, also understand the growth pattern of the data. Lots of us do the computation that, okay, this much data will take this much time to read, and hence it will take minimum of these many hours. Parallelly it will, but we forget, when we do this kind of computation, most of us forget the growth pattern of the data. Okay, and as a general thumb rule, if you are planning for a social application, a B2C application, definitely you should focus on building a good base using big data tools from the day zero, instead of later on faltering and then saying that we need to move our RDBMS solution to the big data, because the growth pattern in case of big B2C customer is actually very, very different. Okay, because the day you do the press release of your application, suddenly there will be thousands of people in few hours. Okay, you'll have to manage it. Okay, so we have, so Abhishek's question is, so most of the difficult work is to present the data in yes, that's correct. And all right, so Spurti's question is, what is the difference between big data and Hadoop? Big data means big is an adjective and data is a noun. So we say a bigger data, while Hadoop is a tool. Okay. Hadoop is a tool to solve big data problems. All right. Hariharan's question is Mahat equally capable of R? Can all work done by R can be done by Mahat? Hariharan, let me answer Hariharan's question. The quick answer is no. R has got vast library, and lots of problems that can be done using those library are not yet ported onto Mahat. Although the work is in progress, the libraries are getting ported, and also newer libraries are being built. All right. Sorry. Now, going ahead, Arvind says, so it should satisfy three V's. Yes. So yeah, that is the way you can look at it. All right. Now going ahead, is everybody okay with this? Next example case we talked about was sentiment analysis. Sentiment analysis is one case where we analyze the behavior of your customers or behavior of public with respect to your brand or your name, and understand whether they are liking it or whether they are criticizing it. Okay, so to do a sentiment analysis, there are many techniques, there are many tools. Okay, so you count likes, how many people are liking your tweets, how many people are talking about you, how many positive keywords are used in the context of your product, and how many negative keywords are being used in the context of your product. And then we sum it up and then we present it in the graphical format. On x-axis we have time, on y-axis we have positive and negative tweets. Okay, and also we draw generally the various campaign we started on various date as a vertical line on this graph. Okay, to basically we try to show that how how is the general sentiment for our product campaign or our brand name, whether people are talking positive or talking negative. So this is called sentiment analysis. And since sentiment analysis depends on huge data, So sentiment analysis depends on huge data, and therefore it's a recipe for the big data analysis. Specifically, the velocity part is too high in case of sentiment analysis. All right. So Jay Parikh's question is there any relationship between big data and data mining? Big data means humongous data, and we do the data mining on big data as well. Just that when we try to do the data mining on big data, lots of existing tools are not able to do it properly. Okay, that's when we try to port it on the big data platforms such as Hadoop or Spark, and or we look for a library which runs on Hadoop or Spark and get it done in the context of big data. All right, now we have a question from Satish. Okay, so Sati's question is, I have a question on recommendation, which is done using Hadoop tool, but processing big data is done offline. It doesn't perform well on demand. So most of these tools, when we talk about churning terabytes of data, it is generally the way we had been trying to use tools like Hadoop, which were batch processing based. Mostly, these tools did not perform great in the on-demand in the on-demand in the on-demand systems. Okay, but having said that, there are other tools other than the MapReduce or Mahout, which are quite useful when you do it on demand. Okay, but the problems like generating recommendations is actually impossible to do on demand. Okay, because even if you have 1,000 nodes cluster, and no matter which tool do you use, technically it's not possible to get the recommendation before in less than 30 minutes if you have few hundred terabytes data. Okay, so that's the reason these tools are mostly the batch processing tools and are not on demand tools. All right, but there is a lot of work. We will also, during this course, we will also go deep dive into Apache Spark and how does Apache Spark solve the problem of on demand computing or real time computing. All right, Satish. So Srisha's question is, what is data mining and when do we use data mining? So data mining is, what does it mean by data mining is looking at the data, deducing the pattern and understanding the data is called data mining. Okay. For example, figuring out what is it that is impacting our output in a factory based on the temperatures of various input points. Okay, is is a part of data mining. We try to understand the data, we try to understand the correlation between various data. Okay, and so that's data mining. Now Hariharan's question is, in general, software product companies, do they use R or Mahat? Okay, it all depends, Hariharan. In case in case they have to churn few the data in lower GBs, then they use R. Otherwise, they have to, for few special problems, specifically problem related to collaborative filtering or machine learning, they use Mahout. Okay, collaborative filtering means recommendation. Machine learning is another level. Although most of the machine learning can also be done in R, but R does not perform when the data grows bigger. So most of the organizations who had been quite used to do the analysis based on sampled data rather than the whole data, they were happy using R. But when they realized that they can do the churning of the whole data using new set of tools, they also migrated. Okay. All right. So most of the modeling they do it in R and then they move to a bigger tool. the tool that can run on big data. All right. Srisha's question is, how is data mining different from Hadoop? Hadoop is a system for doing usual data input and output and running processing. It's just that in data mining with R, they already have a lot of algorithms in place. But in case of Hadoop, the libraries like Mohoth and MLlib are the only libraries available. Okay. So to do the data mining, you should have a good understanding of statistics as well. All right, we have a question from Venkat Somani. Is Hadoop and Apache Spark same? No. Okay, we will talk about this in second half. You will understand it better when I show it in the diagram. Now, Arvind's question is, there is another buzzword called data science. Is data mining and data science relative? Yes. Data mining and data science is relative, just that those people who used to do data mining, when I mean, if somebody knows a real good deal of programming and also knows how to present the data and also knows data mining, they are considered data scientists. Wow, we have got great set of questions. All right, Priyabart's question is, Mahat is built on top of big data. We'll talk about this again in the second half. Do we need to know machine learning, statistics, and data mining to understand and use Mahat? Good question, Hariharan. The quick answer is no. You don't need to understand machine learning, statistics, and data mining to use Mahat. Okay? It is off-the-shelf product which shows that if you give me this input, I'll give you that output. But you have to understand what input to give and what output to expect. All right. Abhishek's question is, Spark can be used for Twitter sentiment analysis like task? Yes, that's correct, Abhishek. Spark also will use for recommendation. Yes, people do use Spark also for recommendation, and it's a little different from Mahat in the sense that it does the processing little faster. Okay. All right. All right, how the data is stored. We will discuss this Baswaras in coming sessions. How is the database data going to be stored? Let me take a step back. So we talked about recommendation engine and sentiment analysis. Then we have problems like search quality and A/B testing. Search quality could be in various ways. So let's say you are building an in-house system which does the search quality. All right. Okay, let me take a step back. So let's say you are building an in-house system for searching things in your intranet. Okay. And this is a small application and it will be hardly storing 200 gigabytes or maybe it will be storing say 50 gigabytes over a period of 1 year. Now, although 50 gigabytes is a big deal, but it's not that big deal if you think about the hard disk. Your hard disk can handle 50 gigabytes easily. Now, so when you are building such a search engine, such a product which has a search engine inside it, you would want to give really brilliant suggestions. For example, if the user is searching for blue dart, you would want to support all the variations of blue dart. Blue space dart or blue continuously dart and BLUE as well as BLOODART. Now, in all these cases, you should be able to give the recommendation to the user, suggestion to the user that, hey, did you mean this particular word? Okay. Or this and this word are similar and therefore you give the result for the other similar words. Okay, so whenever you have to do this kind of churning, you need to build a really sophisticated dictionary of keywords. And that's where to build that sophisticated dictionary of keywords is going to require a lot of efforts. All right. Similarly, in case you have images which need to be indexed and you want to extract text out of images, then processing each image might take huge time. And for this, you might require multiple computers to solve your problem. Then is A/B testing. In case of A/B testing, what does it mean by A/B testing? When so let's take a case of a website like Amazon's website. If we had to change a single feature such as the color of the buy now button, we basically launch the variations. Okay, for 1% users we will show the new design, while for 99% of the users they will keep on seeing the old design. Now, after measuring the feedback of these small set of users, if the feedback is good, meaning lots of people are able to click that particular button comfortably, and only then we change the color. This strategy of testing the design on the customers in the real time is called A/B testing. A/B testing comes from the drug testing world, where we if there is a new drug to be introduced, we test it first on people, and without telling them that whether they are taking the pacifier or taking the drug. So A/B testing is this is how A/B testing is relevant in software development world. So each feature or each variation we test on the end user. Now we just talked about only buy now button. The same it would be true for probably all the things, all the features which Amazon is showing to the users, which means there will be hundred of thousands of variations running parallelly. Okay, if you multiply total number of permutations, you will realize that there is a lot of variations going on website. Not 100,000, but at least 1,000 variation would be going. And to do the accounting for all of this, to keep track of what is being shown to which user and how they're performing, you would require multiple computers to solve this. Okay, and that's where the A/B testing comes into play. Similarly, for telecommunications, the problem is quite relevant. I have at least met 4 or 5 people so far who are trying to solve the telecommunications big data problem. Lot of telecommunication company has already moved on to big data platform, but there are still few companies who are still struggling with their relational databases. While their data, almost every telecommunication company's data goes into uh, terabytes every year. Okay, and they try to use various kinds of systems in order to process and churn the data. And as per they themselves, their existing system is not going to last for more than 2 years anymore. So telecommunications is telecom companies are one such area where there is a huge demand of big data tools and big data solutions. And these are just few examples where customer churn prevention, network performance optimization, calling record analysis, analyzing network to predict failure. These are just few use cases for telecommunications. All right. Now the other use cases are for government and for healthcare. In both the cases of government and healthcare, there's a lot of requirement, but these are not the example customers. There are lots of organizations who have realized the power of data and have moved on to big data and started utilizing the power of these new generation of tools which can churn and store humongous data at a very low cost. All right. So Damodaran's question is, if we move to SSD, is our problem solved? No. Okay. Simple answer is no. First, when you move to SSD, your size goes smaller, right? Each disk in SSD is a far more smaller in size, right? Therefore, you will have more hard disk, and hence you will eventually have more computers. All right. Now, the Mandar and Arvind want to understand A/B testing a little bit more. Coming back to the point again. So, on your website, if you have got lots of users and you are basically observing how are your users responding to a particular change. If you are able to understand whether because of particular change your users are going to get hurt or are going to appreciate, then then you should be able to build an A/B testing environment so that each of the developers of each feature on your website can run multiple variations of their features. Okay, in very concrete terms, imagine you are owning the search results of Google. Okay, for one user you will for and you were pretty happy with your search results. Okay, but there is one new person who suggests a new design for search results. Now, how do we make sure whether the design will work or not? Okay. Earlier in the times of Apple, there was one person who is called product manager and who will call the shots. Okay. Who will do some user study, or who will do some sort of meditation and will confidently say that, okay, this design is better and this design is worse. But in case of today's world, where you have a lot of data, you do not go that way. Instead, for some users, you show the new design. For rest of the users, you continue with the old design and then compare whether new users liked your search results more, or the or users are still liking the older design more. So that's called A/B testing. Okay. So Arvind's point is whether it's test driven development or behavior driven development. I'm not sure whether this term is still popular, behavior driven development, but yeah, it's not, A/B testing is not definitely test driven development. All right. Okay, so Mandar, was I able to answer your question? Great. All right. So there are these many companies who are using big data in the various contexts. The bigger the font, the bigger they were using. So it's basically a slide which showed the instances of Hadoop. Here, since there is no way to find out whether a company is using big data or not, I use the number of Hadoop nodes each company is using. All right. Here are common 11 myths with various I have met with various people. So here are few common myths. First, big data always means data above or in the range of terabytes, and this is definitely not true, as I gave you an example of Google Map, a problem involving maps. In that problem, even though the data was in 100 GBs, it would still be pretty difficult to find the accurate path in a reasonable amount of time using a single computer. Okay. Second was is always about social media, and it does not apply to me. That's definitely not true. It just so happens that in case of social media, gathering data is easier. Therefore, lots of applications such as sentiment analysis is done on the social media. Third is will replace EDW. It will replace enterprise data warehousing. The quick answer is no. Why? Because EDW has got its own use case. And there are some things which are better done using relational databases than using these new set of tools. And therefore, EDW and big data tools will coexist. It's just a buzzword, no practical application. This is definitely a myth because it's not a buzzword like Web 2.0 or those kind of keywords. The reason is that I have seen lots of use cases in past few years, and that is probably the only way forward for lots of organization going towards the big data because everybody, instead of thinking data as a headache, everybody has understood that if we store and process the data about our consumers, we would be able to do a lot of magic. Is a new concept? Definitely not, because I was telling you that. So it's not a new concept. It's basically has been there for quite some time. It's just that now these tools have become publicly available. Six is it will be the future. No, it's the present. Seven is expensive. No, it's just that since there are only few people who are able to solve the big data problems or use the big data tools, therefore, those people are expensive, while the tools are fairly free. I mean, almost free. Okay, and also these tools do not require you to buy a special hardware. You can utilize your existing hardware. Eighth is only for data scientists or is a magic? No, almost all the tools have come up with these big brilliant libraries which have simplified the job for the developers. So while the data scientists keep on producing new algorithms and new ways of representing data, they also make it public or make it available for developers to use those things. And ninth is we have enough hardware, do not need anymore. So big data is not about hardware, it's about the software layer. Whatever hardware you already have, you can utilize that. You can basically connect that in network and run these tools and get your work done. And 11th is big data is about Hadoop. Okay. And no, there are many other solutions which help you solve the big data problem, starting with MongoDB, Cassandra, and even Google Compute Engine. So, big data is not only about Hadoop. Next is that we will build it when we need it. Okay. By the time you realize that you need it, you will have lost lot of data, and therefore it's important to build now so that you start capturing the data instead of deleting it. So Asutosh's question is, what is EDW? EDW is Enterprise Data Warehousing. Okay. Arvind's question is, if big data is not the future, then are there some problem research is going on? So it's not, when I say it's not the future, it's basically the present. Lot of research because everybody has started using big data tools and porting their existing machinery I mean machinery, when I say, means their existing code bases onto the big data solutions. Okay. So Hariharan's question is, the difference between a data scientist role and a big data Hadoop developer role. Okay. Okay, let's take the case of our Hadoop recommendation example. So in Hadoop recommendation example, we were using Mahout. Mahout was taking this three-column data, user ID, product ID, and the rating, and was giving you the results, right? Now, the role of a data scientist is to fine-tune the algorithm. Okay, a role of a data scientist is to understand how can which algorithm specifically can solve your problem, and if they can make that algorithm better, okay, by 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 using various weightages, various configs, or maybe inventing a new algorithm. That is the role of a data scientist, while the role of a developer is to be able to use these algorithm as is without making any modifications, and to be able to churn the data and prepare this three column data that can be fed to the Mahout, as well as when Mahout has done processing the data, the output, the Hadoop developer should be able to take that output and give it to the web application. Okay, so basically, basically the data scientists are generally involved in doing the data modeling, doing the data mining, or sometimes the data visualization, and come up with the various kind of a use case in which we could utilize the customer data. Okay, so all right, so I hope that answers your question, Hariharan. Great. Anuj has also got the answer for the eighth one. Now, Damodaran's question is big data about stored data, or does it cover transient present data hitting their enterprise server, such as both? It covers both. As we talked about three things. One was the data in your databases, which is data in stationary data. Okay, the volume. Second is the number of requests coming in, which is data in motion, and third one is, okay, third one is the complex problem such as recommendation. Okay, so it's about all the three cases. So Mandar's question is, can big data tool work on RDBMS databases such as DB2 and Oracle? I mean, the problem is not these tools running there. There is no such use case where we would like to run Mahout on top of our relational database. Okay, and I mean, how should I explain this? So the question is, can any of these big data tools run on top of a relational database? So whatever these tools are providing, that is already provided by relational databases. Okay, but since relational databases could not do the job of handling lot of data, that is why these tools are invented. And these tools, although at some point all of them can connect to the relational database and bring the data from the relational database for the processing, but the objective of none of these objective of these tools is to churn the data on the relational database. All right. Now, Hariharan's question is, so data scientists mainly concentrate on contributing to Mahout, whereas the big data developer uses Mahout like Blackbox. Correct. That is correct, Hariharan. So his point was that data scientists mainly concentrate on contributing to Mahout, whereas the big data developers use Mahout like a black box. Okay. Yes, that's correct. And or a data scientist not only contributes to Mahout kind of tool, but also make the overall recommendation better by fine tuning or configuring the algorithm. So, for example, there are around 11 algorithms for doing the recommendation. Now, which one to use when is the role of is the role played by the data scientist. Data scientist will tell you for recommendation, please use say Tanimoto coefficient. Okay, so because that fits into our kind of requirement. Okay, although the difference between one to another will be hardly of 1% accuracy, but still that is the role played by data scientist. Now, Asutosh's question is, can we use big data in .NET application also? So it all depends on what exactly are you trying to do and how exactly you can do that. All right. So if you are trying to do MapReduce using .NET, then it is going to be a little difficult, but definitely possible. Okay. And in case you are trying to call the database from your say Hive, you are planning to call from your C sharp code, that you can do. If you're trying to connect to HBase, that you can do from your C sharp code. All right. Arvind's point is one point to add here. We are not storing every data, example transaction logs, clicks into DB2. Correct. That's correct, Arvind. So Hariharan's question is very good question. How can we prove the correctness of recommendation? Can somebody answer this question? It will be brilliant. So how can we prove the correctness of recommend? So okay, let me ask you this way. One person comes to you and tells you that it can predict your future. How will you test their correctness? That's correct, Abhishek. Abhishek is saying by actually verifying if that person really rates that movie. Yes. So, yes. So what we do is if you have a data of, if you have say a million ratings by various people, so you will split it into 50-50 generally or 80-20. 80 on the basis of first 80% of the ratings, you will generate the result and then you compare the result against the rest 20% and check whether the prediction held true or not. Okay, and that is how you generally test the algorithm. Yes, that's correct, Shyam. Thank you very much. Shyam's point is we use training set to test our model. We then test it on the test data set and check for accuracy. Right. All right. I think I've not skipped anybody's question. Okay. Now we have Damodaran's question. Where does this big data tools run? Is it at the application level or is it capable of running at layer 2 or above, like deep inspection packets in network protocol stack? So let me uh, okay all right, so his question is on what layer does it run? So all of these big data tools are just on software layer. None of these are on the hardware level. Okay, so none of them work on, they're not building a new protocol. They're just network services or other clients. Okay. Yes. All right. Now, great set of questions and great set of answers by all of you. Great. Now, moving ahead, I think we should take a break now for. So let's take a break for 10 minutes and back by 10:22 p.m. IST. All right. So, should we start now? Is everybody back? All right. All right. So, Manisha's question is that can you once again explain how the correctness of recommendation data is checked? Okay. So, the general strategy to figure out the correctness is basically dividing your input data into two parts. One on which we'll run our model, and second, against which the results of our model will be compared. Okay, it's like saying that, okay, there is one person who have come to tell you your future. You first ask him about your past. Okay, if he's able to tell you the past correctly, chances are that he will be able to predict the future as well. Or, okay, so basically, to this model, to say recommendation engine Mahat, you will give the half of the ratings only. And once you get the result from Mahat saying this person will like this person will like this movie, then you compare this result against second half of your input data, checking whether this person actually like this movie or not. Okay. Or in case of Amazon's purchase order, say there is some we are trying to validate whether a recommendation model will work or not. So what we do is we'll divide the total purchase history of all the people into two parts. On the first part, we generate the recommendation saying this person will likely purchase this product, and then we compare with the second half saying checking whether this person actually purchased or not. Okay, and then compare how many of the people actually purchased the product, and the more number of people who have purchased the product, and meaning the better recommendation or better prediction, uh, I mean the more the number, the better the prediction, the more closeness in the result. All right, does it make sense to you, Manisha? Great. All right. So, brilliant set of questions. And so now the salary trends is usual stuff. You can go to indeed.com or go to any of the job portals and you will find that Hadoop is probably the hottest job out there. Okay. Hottest, job with respect to the salary and with respect to the career. And Hadoop remains like hot technology for quite some time. Now, there are multiple way you can solve your big data problem. The most common one is using Hadoop. Then you have systems like MongoDB, Cassandra. In case of Cassandra, you can store a lot of data, but the churning and prediction, and if you want to store a lot of files, Cassandra may not be a great solution. Same is the case with MongoDB. Both Cassandra and MongoDB provide you a great database, but may not be the solution for many other problems. Okay, so if you are building your organization's big data platform, Hadoop is something which cannot be ignored. Hadoop provides you many things and is probably the most complete suite of components as compared to any other. For that matter, Spark is also kind of part of the Hadoop ecosystem now. Okay. All right. So moving ahead. And if you are okay with moving your organization's data onto Google Compute Engine, then it's okay to go with the Google Compute Engine. And those who are wondering about Azure or HD Insights from Microsoft, HD Insight is nothing but Hadoop on Azure. Okay, Hadoop on the Azure, as in Azure is a cluster provided by Microsoft. Okay, so Hadoop, since it's written in Java, so it can run on Windows as well. And that particular package which runs in on the Windows is called HD Insights. So Anuj's question is, are these tools substitute to each other? Not really, not really. MongoDB is great when you are trying to store the documents. Cassandra is great when you are only talking about a database which looks like relational database. Google Compute Engine is great if you are just trying to you are okay with moving your data to Google's premise. But probably Hadoop is more of a complete solution. Priyabrat's question is, data cleansing and transforming also a feature of big data? So big data tools, I would say. Big data is just a keyword. Okay. So data cleansing and transformation is a part of all of these tools, whether Google Compute Engine or Hadoop or Spark. Okay. Because as opposed to the way we had always looked at transformation and cleansing, in case of big data, when the data is really humongous, the transformation, cleansing, and transformation and transport are a very big challenge. Okay, and because as we were counting that to read a terabyte of data takes around 6 hours, and to write a terabyte data over the network might take couple of days. Okay, so transport engineering is lot required, and big Hadoop and these all products try to provide an effective means of transporting and transforming. Now, Abhishek's question is, column oriented databases are efficient in some aspect over Hadoop. So they are, see, there is a database called HBase, which is a column oriented database that is provided on top of Hadoop. That's also pretty efficient. That's also quite efficient. Okay. And okay, so there is, I mean, we cannot generally say that column-oriented database are efficient because Hadoop also contains a column-oriented database. But if you just wanted a column-oriented database, not the full suite of component like file system, this, that, then probably Cassandra will do a better job. Or maybe MongoDB will do a better job. Kayur is saying, sorry, I joined late, but HBase and Hive is part of Hadoop. If yes, then what is the use of them? We'll talk about it, Kayur, don't worry. All right. All right. So now the main question. Now, till now we have been talking in general, what is big data? What are the what what is the myth? What are the job scenario? How do you characterize big data? How do you identify? And what are the use cases? Now, now we are going to talk about Hadoop. Hadoop is one of the solutions or the platform to handle big data. It started with only a database, a file system, and a compute engine. Now it's a full suite of components. So, okay, from a bit of history, Hadoop was designed by Dog Cutting and Mike Caffarella when they were trying to build their Nuts search engine project. Then the name of Hadoop is based on the toy elephant's name, and Basically, when they were trying to build their nut search engine, they were almost stuck when they had to handle humongous database. They realized that to handle the humongous data of the crawler, the usual file system or usual database cannot handle it. And that's luckily at the same time Google published these three papers. One was called Google File System, other was called Google MapReduce, and third one was called Google Big Table. And these both of them implemented those three papers, and Google File System became based on Google File System. They built something called Hadoop File System. Google MapReduce is Hadoop MapReduce, and Google Big Table, the implementation of Google Big Table became HBase. All right. So other important aspect of Hadoop is that its license is open source, which means you can use it for academic purpose, professional purpose, or any purpose without having to worry about violating any license. Okay. Apache license is probably the most liberal license around. Okay. So you can use Apache license without any problems in even the production environment. And probably this particular thing, which is Apache open source license, this particular license bit is the reason why Hadoop became so popular immediately. Although many other people started implementing Google File System and MapReduce, and there are other systems as well, but they did not become popular because they were not as open as Hadoop. Okay, it's quite popular, powerful, and supported, which means there is no problem in adopting Hadoop. There are 3 4 companies, or I know at least 4 companies who provide support on Hadoop. One is Cloudera, Hortonworks, Qbol, Mapr, and similar companies. And it's a framework to handle big data. And when we say handling big data, it means reliable, scalable, and distributed computing. Okay, and it's written in Java, as in it's written in Java with the mindset that Hadoop will be running on many kind of devices. And because of this feature, now Hadoop is also ported onto Windows, which is called HD Insights. So Bhaskar's question is, can we use Hadoop to do the analytics of existing relational database if it's too big? Yes, you can do it. What you can do is, if you have a huge database, you can move that data to HDFS or Hive, and then you can do the analytics on top of it. Okay? All right. So this slide will probably answer lots of your questions. Okay, so before I get into this slide, there is one more question that needs to be answered. Shisha's question is how Cloudera, Hortonworks platform are different. So the way they are providing the provisioning system, since Hadoop involves so many components, okay? So in both the offerings of Cloudera and Hortonworks, these components vary, okay? One of them include the I mean, there one or two components are differing. I think in terms of either mm, Taze is including in Hortonworks, while Cloudera has some other tools also. So there is minor difference in offering. I mean, there are one or two more tools in either side. Plus, Plus, in case of Cloudera, they have their different manager. Manager is used for installing, uninstalling components or adding more machine or removing machines. So Cloudera and Hortonworks have different managers. In case of Hortonworks, they use Ambari for managing the cluster. Ambari is an open source tool maintained by Hortonworks, while Cloudera's manager that helps you provision the cluster is very specific and is very closed source. It's not open as Hortonworks. All right, great. So, Mandar, I'll answer your question after this. So, Satish's question is, so Hortonworks can be used in production freely? That I don't know. That I don't know. I need to check their license. Okay. If their license is Apache license, then it's okay to use it. But if they have changed the license, then it's another issue. But they are shipping the same open source Hadoop project. Okay, so they really cannot put the restriction. They can only put the restriction of licensing only on their own components. Okay, because and in case of Hortonworks, since there's only one extra component called Ambari, which is also Apache license, so I don't think there is any problem in using Hortonworks in production environment. Okay, but definitely go and review the Hortonworks licensing. All right. Let me answer Mandar's question. Did you see anywhere RDBMS migrated to big data databases? At some places, yes. So some portion of the data is generally migrated to the big data database, such as MongoDB, Cassandra, or maybe the HBase. All right. So Michael's question is Yarn same as MapReduce? I'll explain you in a short while. All right. So, okay, hold on. You keep on asking the question. I'll answer after this slide. All right. You continue asking question. I'll not be answering for maybe 1 minute more. You just let me explain these various components. All right, so out of these whole suite of components, the most important component is the Hadoop distributed file system. Hadoop distributed file system is a file system where we can put file. Just like you have C colon, D colon, or a normal file system, this is a file system which is spread across multiple computers without you knowing about it. So HDFS is a place where you can keep on storing the files without having to worry about maintaining the backups, worrying about uh, worrying about how to distribute load and all that. All of those problems are taken are well solved by HDFS. Okay, so Hadoop distributed file system is the base for all other components in Hadoop ecosystem store the data in HDFS. Okay, now on the top of HDFS we have the next is Yarn. Now, since we have stored our files, our data on HDFS, to churn the data most efficiently, we use Yarn. Because when we store terabytes of data, it does not make sense to, to read the data from HDFS, then process the data and write it back. Instead, we distribute the computing onto the full cluster. So this HDFS would be running parallelly and utilizing the storage space of hundreds of computers. Okay, so if you have 100 computers added into HDFS cluster, Hadoop cluster, all of the 100 computers will be utilized to store our data. We'll discuss how exactly is it done, but for now understand that it's a distributed file system. Next is On top of HDFS, if we have to do any processing such that there is a minimum amount of transfer of the data, we the utilize a framework called yarn. Any computing we do using yarn, it basically utilizes hundreds of computers parallelly. Okay, so that one portion of the data being processed by one computer, second portion of the data being processed by second computer, and so on. Okay, so that way yarn is a compute engine. Yarn stands for yet another resource negotiator. Yarn makes sure that you get the computers to get your work done. Now, on top of yarn, there are many paradigms which have been developed. So you will not be using yarn directly. You will be using yarn by the way of yarn is like an operating system. The way operating system makes the resources available to you, makes the CPU available to you. Similarly, yarn makes the various computers and resources available to your computing requirement. And you use yarn by the way of either the Spark or by the way of MapReduce or by the way of any other third party libraries. So but you will be either writing MapReduce code in one way or the another, and that MapReduce code will be executed on the cluster using yarn. Same is the case with Spark. We will be writing our program in Spark way, and then the Spark will ask Yarn to execute the logic on multiple computers. So that's the relationship between Yarn and MapReduce and us. And Yarn will be knowing very well about HDFS, okay, so that the instead of moving the data, Yarn will move your logic from one machine to another. So that because when we deal with data at one end, either we can move the code or move the data, right? If you are moving the data, we are talking about moving few hundred terabyte from one machine to another. While if you move the code, it will be few bytes or few kilobytes to move from one machine to another. Therefore, instead of bringing the data to the code, we take the code to the data, and that's the role of yarn. Next is the HBase. HBase stores the data in a sort of tabular format. If you have a lot of read write requirements continuously, and you have to alter the data record wise, just like the way you do it in case of Excel sheet, okay, or in case of a relational databases where you alter a row, delete a row, and so on. Okay, if you have that kind of requirement and you have billions of rows and millions of columns, you would use HBase. Okay, HBase is the database. So few of us would be confused about whether to use HDFS or HBase. The answer is pretty simple. Okay, so in our normal system, HDFS is like your file system. We have copied our file into C column and that folder. Okay, and database is for tabular manipulation. Okay, in the same way, HBase is for tabular manipulation, and for file wise work, you will use HDFS directly. All right. Now on this, there is something called Hive. HBase does not provide you an SQL engine. All HBase provides you is get and put. Okay, get this particular cell, write to this particular cell. That's all. But we are lucky that there are some libraries which provide us that SQL functionality. One of that library is Hive. Hive Hive makes it possible to write your logic in SQL that would get converted into MapReduces and will run on the cluster using Yarn. So using Hive, you do not necessarily have to code in MapReduce. You can simply continue to write your translation logic or your other logic in SQL. Okay. Similar is the Piglatin. Piglatin is a very simplified SQL and is designed for unstructured data or semi-structured data. Okay, so Piglatin can also be used similar to Hive, and you will be writing your logic in something called Piglatin instead of SQL, and that will get converted into MapReduce under the hood and get executed via yarn on the whole cluster. Next is Mahout. Mahout, as we discussed, is a machine learning library and does the job on the cluster. All right. Then there is Flume and Scoop. Flume makes it possible to copy the data from unstructured sources, such as your web servers. If you want to copy the logs from your web servers, and at a very high pace, at a very fast pace, Flume makes it possible to copy the data from the network onto the HDFS. While Scoop, okay, Scoop will copy the structured data from your MySQL, Oracle, or any JDBC or relational databases onto Hive, HBase, or HDFS. Okay, so so Scoop and Flume are for transporting the data. Now, when you have these many tools and in a project, you would require many things. First, you will copy the data, you will cleanse the data using Hive or Pig, and after you have cleansed the data, you will feed it to Mahat. Mahat will give you some recommendation on some predictions. Once that predictions is done, you will move the result using Scoop onto your web server, and there you will display it to your end users. Okay, so if you see that you have involved almost all the components in this whole in a single project. Now to get it done properly, you would use a workflow engine called Uzi. You would use Uzi to chain all of these tasks together and get it done. Similar to the way you had been using Apache Ant or Maven or Make in case of C++, and Ant in case of C Sharp. So similar to that, there is Uzi to which you will provide your XML, and Uzi will run your various tasks on the cluster, and once it is done, it will notify you. So that is the role of Uzi, and you can interact with all of these tools via command line, via web browser, via programming language such as Java and Python. All right. Now let me try to answer your questions. So Michael, was I able to answer your question? Is yarn the same as MapReduce? And Kayur, was I able to answer your question whether Hive is a part of Hadoop? If yes, then what we use them for? All right. Now Arvind's question is what is the tool to process semi-structured data? You will generally use Pig for processing the semi-structured data. Say you have CSV file, you will load that CSV file into Pig. In Pig, the beauty is that you don't have to specify the full structure. Unlike SQL, in SQL you have to specify the data type of each field, right? So you can use Pig and Piglatin for processing semi-structured data. Now Pawan's question is Hive on HBase the equivalent of SQL on Oracle? That is Pawan's question. It sounds like that way. Okay. The difference is that Hive does not provide you a way to insert update records. Okay. For that you have to directly interact with HBase. But that's a good analogy. Now Hariharan's question is what is the difference between installing Hadoop by ourselves than using Hortonworks, and what are the complexities that Hortonworks make it easy? So there are few things which Hortonworks has made very, very easy. First, once you have installed the Hadoop Ambari agent on the machine, you do not have to yourself download or configure anything. You can do everything from the browser. Okay, you don't have to manually do each and everything. Those are really, really seamless. I have tried both the ways, installing Hadoop by ourselves or installing Hadoop using Ambari. Okay, I found using Ambari is far more easier. Okay, and using Ambari, it's you are basically using a Apache license product, so it's not too much of a problem. All right. So Mandar's question is there any analytics application which produces big data reporting? So most of the big data reportings is done using the traditional tools. Okay. When you are preparing a report, right, you always prepare the report on a very smaller data. Representing billions of record in a report does not make much of a sense. So what you do is, using big data tools, you convert the bigger data into a small insights, and then you use the traditional BI tool to connect to, say, Hive or HBase, and then represent the data in the report. All right. Or once you have generated your insights using Mahat or using your Hive Pigletin, using the whole cluster of computers, you move those insights or you move that the outcome onto your MySQL server using a scoop, and from there you can continue to use your existing BI tools to represent the data for human consumption. Mm, all right. So Shisha's question is that can Yarn execute only one program at a time? No. Yarn has been designed such that you can queue a lot of programs on it. That is why a lot of jobs can be executed on Yarn parallelly. And that is probably the main feature of or main reason why Yarn exists. Two, first, anything you tell Yarn, it executes on multiple computers. Second, it does the time scheduling, it does the scheduling of tasks onto various machines and monitors them just like an operating system. So Michael's question is, if Scoop and Flume are responsible for data transport, would they be considered the bottleneck for data I/O? Scoop and Flume are definitely the data import tools, data transport tool, and generally when you observe a bottleneck in case of big data, you need to observe who is slower. So Flume may be the source from which the Flume is a- absorbing the data. Is that slow, or the pace at which we are writing to HDFS is that slow? Okay, you need to observe that. Only then you will be able to figure out who is the bottleneck and what needs to be solved. Generally, the source from which the Flume is reading data, either that one is slow or maybe your network is slow. Okay, but Flume and Scoop has been designed in a manner that they aggressively transport the data parallelly onto onto HDFS cluster. Okay, they utilize multiple machines simultaneously to get the work done. All right. So yes, yes, Hariharan, Uzi is similar to the build tool. Okay, very good question. And okay, Basura's question is HDFS is a storage, NAS and SAN. Yes, it's far better than NAS or SAN. We will see it later. How? And but it's similar to the network attached storage you can think of. All right. Kirupa is saying, please provide more information on Flume and Scoop. Flume and Scoop both are, say, commands which transfer the data from from one machine to another. Flume will listen to the network service and read data from there and then push it to the network. Okay. So when we will go into more details, we'll dedicate one full session on Scoop and Flume and Uzi. All right. Thank you, Damodaran, if you find the explanation of slides awesome. And now, Scoop is only getting data from relational database to HDFS. If I want to get data from NoSQL to HDFS, how do I do it? So for that, you will have to use your own connector. For example, in case of MongoDB, to connect between MongoDB and Hadoop, there is a tool called Mongo Hadoop. And that Mongo Hadoop basically connects to MongoDB and can push the data to here. Or to be honest with you, you can write your own small program which can connect to the MongoDB service, at the same time can connect to the HDFS service and copy the data. All right. So now Kayur Shah's question is Hive MapReduce and HDFS, but not to HBase. So Hive can also do things like Hive. So the diagram, let me just copy this question to my. Okay, so the question is this: Hive to MapReduce to HDFS, but not HBase. That is Kayur's question. But so the thing which you I forgot to mention that Hive can also churn the data which is on HBase. Okay, so this is also true. All right. Same is the case with pig also. So you can have things like here, you can have things like pig, all right, and then utilize it. All right. So Anuj, that answers your question as well. Now Savita's question is whether how do we decide whether to use pig or hive? Okay. So if you have if you are comfortable with pig, you use pig. If you're comfortable with hive, you use hive. It's as simple as that. Okay. If you already have a lot of SQL in the legacy system, you generally go with hive. Otherwise, you go with pig. Okay. All right. Now, question is, how do I transfer data from HDFS to HBase and vice versa? So that's a Satish. This is Satish's question. So how do you load the data from HDFS into HBase? For that, you might have to write your program to import data from the file which is lying in HDFS into HBase. Okay. Now, Pawan's question is, how will the interaction like insert and update happen? Interaction and update, in case of HBase, there are few libraries which provide you an SQL kind of insert and update layer on top of HBase. Okay. Satish's question is, can we replace HBase with MongoDB and use Hive as interface? So that will not be very optimum if you try to replace HBase with MongoDB, because MongoDB again we'll have to try to store the data in HDFS and all that. That becomes a fairly unoptimum solution. And all of these components or all of this technology is about optimization. All right. Anu, Anuj, was I able to explain? Okay. Yes. So we will cover all of these tools one by one in details. There is one more tool which is not mentioned here, that is Zookeeper. We will discuss it during one of the sessions. Okay. How does MapReduce code get executed on all the systems? So we will discuss it maybe in the second session, and we'll describe it in detail. How does it get executed? So maps get executed on all the systems. Maps will convert the data into key value that will get accumulated, and then so I mean that will little get into more details. So we'll go step by step and go into the details. All right, Abhishek. Okay, now Mandar's question is, if we use MongoDB, where it would be in this layer? Okay, so in this layer, the problem with MongoDB is that MongoDB has its own format, okay, and own file format, okay, and you can have a look at one of the videos which I have posted on Mongo Hadoop. Okay, there is a connector called Mongo Hadoop. You will be able to understand it better. So it will be difficult to put that MongoDB into any of this picture, because that will be mostly outside of this ecosystem and trying to contact any of these services. All right. Now we have Arvind's question. I tried to work with Hottenworks Sandbox, but I found that it slowed your laptop badly. That's right, Arvind. That is the reason. So his question is that when you try to install Hottenworks virtual machine or any of these virtual boxes, it slows down the laptop. Yeah. So that's exactly the reason why we launched something called Cloud Labs. Okay, so that our students can really feel that first Cloud Lab has many computers underneath it. Okay, so our student can really feel that, okay, this is how the cluster works, this is how the cluster really works in an organization. Okay, second, when during the class, if the Cloud Labs is not really running on your machine, all you're doing is connecting to the Cloud Labs using either the browser or the putty, then your laptop will not slow down. Okay, so those are the reasons why we launched Cloud Labs for our students, and that's probably our one of the USPs. Okay, and it's not a problem with Hortonworks. When you think about all of these components, you're trying to squeeze them into few GBs. Okay, then it has to consume CPU and memory anyway, right? All right. All right, Asutosh, your question is let me explain more about Uzi and HBase to insert an update. Do you mean that I should explain again? Now, all right. Now, Srisha's question is if two jobs need to access the same data node, then will it execute two jobs at the same data node? That's correct. It will execute two jobs at the same data node. We'll talk about these details again. Now, Damodaran is saying that the blocks below Hadoop blue bar is the data feeding, and anything above is for data research and analytics. So, kind of yes here, but it's just pictorial because in HBase also you can insert the data from outside. Okay, you can insert the data into HBase from outside. Similarly, into Hive also, you can insert the data from outside. Same is the case, not with the pig. Okay, so all right. Now, Basra's question is if it's SAN NAS, it's connected all the machine part of Hadoop group. We will discuss the difference between SAN and NAS, and you will understand the difference. So Kayur's question is to learning Hadoop, we should have mastery on all these components. You on all these components. So when we use say that you know Hadoop, you should know how to use these components. Okay? You don't need to have like a PhD on all the components, but you should be confident about using them and when to use what. All right. Hariharan's question is there any significant difference with respect to performance between Pig and Hive? So the answer is yes. Pig has been designed in for the performance reasons. Okay. Pig has been designed from bottom up for performance reasons. Okay, so Big provides you many syntax to do a lot of performance optimization, which are not yet provided in Hive. Okay, so sometimes it becomes very obvious that such problem, if we if we do it using Pig, will be considerably faster. Okay. Anuj's question is, can both Hive and Pig be used for both structured and unstructured data? So Hive is very difficult to use with unstructured data because in Hive, because it behaves as if it's really a database. That means before loading the data itself, we have to create the table, right? And therefore we have to define the columns and this and that. So it becomes very difficult to use SQL for ETL, meaning transforming the data from one form to another, or transforming the data from unstructured to structured. Okay. Therefore, Hive is very difficult to use with unstructured or semi-structured data. All right. So Michael is saying that I do not understand what Pig is. Pig is just like so in Pig, Pig is a client in which you write queries in SQL where you can read data from HBase, HDFS, and then do group by, filter by, join this data with that, and then whatever is the result, you can store it back into HBase or HDFS. Okay. So similar to what SQL does for us for churning the data, Pig also does the same thing. Just that Pig is heavily simplified. Second, Pig is designed bottom up for big data use cases. Okay. I hope that answers your question, Michael. All right. Now, Satish's question is, so to bring data into HBase, we first bring data to HDFS and then HBase. Not really. You can directly also talk to HBase. HBase runs as a service, so we can directly connect to HBase at a particular port and start writing the data into HBase directly. Okay. So that also means that HBase can behave like a traditional database, or HBase can behave like the data store for your web application. If you have a web application which has millions of requests coming in, you might want to use HBase in those cases. You might, instead of MySQL, because HBase can handle huge load at the same time. All right. Now, Arvind's question is, what is Kafka and Impala? Impala is just one implementation of uh, one algorithmic change, so we won't be discussing it. Kafka is a queue. So in an organization, so communicating in an organization across many web applications or many inside applications, it's very difficult to use a database. Okay. For example, so in these circumstances, when there is a lot of communication between one end to another end in an organization, you generally use something called enterprise event bus. Okay. Enterprise service bus, or queues. We call them queues also, and Kafka is one such queue. Okay. So in Kafka, all the applications will keep on writing to it, and the nodes which want to listen or read data from Kafka, they will read from Kafka continuously. So you can think of Kafka as a very big queue, or very big pipe. On one end there are some applications who are writing to pipe, who are putting the data into the pipe. On the other end there are many applications who are reading from pipe and churning it and pushing the data at various places. Okay, so that is Kafka or any queue. If you have semi-structured data, you use, whether to use Flume or Scoop, you always use Flume in those cases, because Scoop is only for relational databases. If your if your data is lying in your relational database, you will use Scoop. It's very straightforward. Yes. So Satish's question is, Hive is a SQL interface, not data store. But I heard you say that you can store data in Hive. Yes. So Hive is basically a very thin layer of interface. Okay, and Hive present itself as if it's a database. So you create table in Hive, you push the data into Hive, but effectively all Hive does, when you push the data, all Hive does is put the file into HDFS. That's all. Okay. So, but I mean, there is no special format in which the Hive stores the data. It just puts it in a folder in HDFS. That's all. Okay. Also, Hive also give you a service, JDBC service, such that you can connect from JDBC onto Hive and present the data using your standard BI tools. If you have BERT, you can straight away use Hive to present the data lying in HDFS. All right. You will understand this difference when we go through one Hive example. So Mark's question is, yeah, all right. Now Priyabharat's question is, can you explain Oozy again? Oozy is nothing but when you have a lot of things to do on the cluster, some in Hive, some in Pig, some in HBase, some in Flume. You basically tie them together using a big XML, and hand it over to Uzi, and Uzi will execute all these tasks one by one, okay, and get it done, just like Apache Ant. All right. Mark's point is that have you covered everything you wanted to cover in this session, or are you just open to QA? So, all right, that's a valid question. So, my plan was that if time had permitted me, we could have covered more, but we can cover more in the second session. Okay, no issues. But the answering to the question answers is probably more important. Okay, Savita's question is the structured and unstructured data stored in HBase, or is the reference node stored in HBase? Okay, is the structured and unstructured data stored in HBase, or is the reference node stored in HBase? So in HBase, you generally store the data which can be represented in tabular format. Okay, and what exactly does it mean by reference node? Okay, all right, all right. I think when we discuss more about HDFS, you will get the answer about the reference node and other stuff. Okay, so in HBase, you generally store the data in a tabular format. Okay, in a very simple words. Okay, now Kayur's question is related to career. I think Kayur, you can drop me an email with this. I'll try to answer. Okay, you can drop an email at hadoop@nobigdata.com. Hadoop@nobigdata.com. All right. So that I'll try to answer your question. Now, reference node from, okay. No, it's okay. I think, see, the Damodaran's question is maybe we should have 10 minutes cut off for question and answer. The thing is, this session is more about question and answer. Okay. In the first session, people have a lot of questions. In the second session, when their question get answered, because everything else you can actually find here and there, you can dig each and everything. But when it comes to question, that's the reason these trainings exist. Okay. Right, so my intention is to be answer individual questions. Arvind's question is, what is the AND data format, meaning structured, unstructured, or semi-structured into XML? So every tool has its own internal format. HBase has its own internal format to store the data. HDFS stores the raw data. It doesn't reformat or do anything with your file. All right. Mandar's question is, how can we see today's recording session? This recording will be posted and will be made available to you. Santos's question is, by what point should I be knowing Java in this course? Okay, I am from mainframe background, so okay. So when we write MapReduce, there is one session number 4 where we will be discussing how to write MapReduce in Java. While in session number 3, we will see how can we write MapReduce without touching the Java code. Okay. So using something called Hadoop streaming. So, for writing MapReduce, you don't necessarily need to know Java, but if you have a special format or you have to do really specialized work, then knowing Java becomes inevitable. You need to know Java in those cases. But if you have to just churn the data, most of the time your Hive query or Piglet inquiry will suffice. You would not need to write MapReduce. Okay, and in case you have to write MapReduce, you can write it in Python. You can write it in your the language you are comfortable with. So, like for example, the whole recommendation engine I wrote in Python without having to worry about Java. Okay. Now, under okay. So Savita's question is, underlying data is stored in HDFS, whereas HBase has some reference node to HDFS. Okay, so the way HBase stores the data is into files, just like your MySQL stores the data into files, and those files of HBase are lying on the HDFS just like normal file. Okay, so whenever you are storing data, you can actually look that in the HDFS folder, that here is the data is stored from HBase. Okay, just that the files will be in a format which is a binary format, so you won't be able to see the internal data. Okay, so the HBase basically stores the data in files in HDFS. All right. Yes, Kayur, Hadoop at knowbigdata.com. That is the email. If you have, you can send that individual question about the career. I can explain that. All right. Yeah, that's correct, Satish. Now, so Srisha, don't worry about HBase right now. When we go into, we'll have a full session dedicated to HBase. Okay. Whenever you have to store data in tabular format, you store in HBase. Or specifically when you have to manipulate the records or cell wise each and everything, then you use the database. Just like why you use MySQL. Okay, so almost done with the questions. Shisha's question is, my doubt is we store data in data node, then why do we need HBase? You will understand this, no worries, okay? Pawan's question is Pig difficult to learn? No, it's pretty simple and straightforward. So is there a place where we can write PLSQL equivalent script using Hive? You can do that. All right, Pawan? Using Hive, you can do that. And yes, Satish, you will get this PPT downloadable. And the next session will be tomorrow. And for next session, you will have to enroll for the class. Okay. Vignesh says, question is it true that Spark supports real-time processing? If yes, how does it stand out in architecture to support that? Okay. So we will show you in the session number 11 a little more deep dive into Spark, then you will be able to understand it. All right, Vignesh? And Damodaran's question is, when you say HBase, is the compute engine stores the hash of files? No, compute engine basically stores the full file, not hash of the files. Okay. Otherwise, if it's storing the hash of the files, it won't be able to recover it, right? All right. So Now, Priyavrat's question is Yarn is like OS. How is Spark interface? So basically, Yarn is like OS, and Spark, whatever code you write for Spark, that will it will hand over to Yarn. Okay, Yarn is a resource manager basically. All right. Pawan's question is, can we have the schedule of classes to plan for attendance? So, I mean, just go to our website, No Big Data. You will see the schedule there, and that will be better. Okay, and please go through the uh, admin console and also go through the question and answers from the quiz for this session. Just complete the half of the quiz, not the full, because there's a lot of questions left. A lot of section is left, which will be covered tomorrow. Okay. Savita's question is, are there any common challenges using Hadoop? I mean, as usual with all the technologies, Hadoop also poses the challenges. If you do not know the details of the platform, you might face a lot of challenges. Okay, specifically with respect to trying to fit the older paradigm onto Hadoop is what creates a big problem. Unless and until we understand that Hadoop is to be used only in the circumstances where your existing tools fail. Okay, most of us do not understand that part. Okay, but when we have few hundred records and we are trying to use Hadoop just for the sake of it, those are the things that's the biggest problem which I've seen in past. All right. So yeah, Satish, you can go to the website and enroll for the course to for the rest of the sessions. So Michael's question is, will you show us how to set up a cluster on our own machine in addition to your network? Yes, we will show you that. Okay. The virtual machine setup you can do on your own machine, and we have the detailed guideline in the documentation. All right. So Damodran, I couldn't get your question. So hash is the index of files stored in HDFS. Okay. All right. So Kayur Mahat is a library of algorithm and Zookeeper is a coordinator. We will discuss both in detail in session 8 and 9. Akshay's question is, if we enroll for this course, then only we will get the recording for this, right? No, for there are 11 more, I mean 10 more sessions for to cover in the details. Okay. Uh, we, and for those you have to enroll. This recording you will get for free. I mean, there's no problem. Everybody who is attending the session will get the recording along with the presentation, so don't worry about that. Okay. And yeah. Abhishek's question is how to use Cloud Labs. Will there be some detailed explanation? Yes, we'll go through it tomorrow in the first 15 minutes. So, all right. So, all right. So, Arvind, what is your question exactly? For this is the address for what? All right. So, yeah, you can log in here for Ambari console. Okay, right. So, so this is the first class out of 11 sessions. Okay, and this is generally open for all, the first session. And from second onwards, you can join them, enroll. Okay. All right. So those who want to enroll, you can open the No Big Data and enroll. All right. So there'll be 10 more sessions, and you can continue. And yeah. Okay, then that's pretty much for today. Yes, we'll be working on a project, and yes, it will also involve Spark. Anu's question is credentials for Ambari. Anuj, you can have a look at the session number 1. There you will see the document. Under that you will see the login and password for Ambari. Okay. So if you have enrolled for the course, you will see that. Yes, most of our sessions are hands-on. Since the audience for the first session is wide, as in there are all kind of people from all walks of life, they come to attend the first session number first. That is why session number first is kept as fairly generic. Okay, these sessions are on every weekend. So So one course is starting from today. This was the first session, and other will be starting on 25th July. These are Saturday, Sunday, 3 hours each, and total of 33 hours. And this is the fee, and you can join that. All right. Okay, then. If you have any questions, feel free to reach us at No Big Data. And if you have any technical questions, drop us an email at Hadoop at No Big Data. But it will be preferable and you will get a quicker answer at reaches at no big data, right? All right. So Anuj, yeah. So yes, Anuj. So generally what happens is we promise to everyone as 11 classes. Okay. And in case there are a lot of questions and there are, if people want to, there are a lot of discussions and there is and sometimes it just spills over to 12 sessions. Okay, but we do not promise 12 sessions, we always promise 11 sessions. All right. So if you are not able to attend any of the sessions, the session is recorded and always made available to the class. Okay, every session is recorded and made available just like this one. Yes, the all the sessions of this course will be at the same time from 8:30 p.m. to 11:30 p.m. in evening on Saturday and Sunday in IST. All right, that was pretty much, and feel free to give us a call on these numbers. And if you have any questions, okay, Kayur. So Kayur's question is there any placement support? We have some recruiters tied up with us. We generally forward your um, CV to them, and that's all. Okay. All right. We'll see you tomorrow. Have a great day. If you have any questions, feel free to call us on these numbers or drop us an email on this. And see you tomorrow at the same time. And in case you have not enrolled, you can go ahead and enroll. Okay. And yeah, from the website. Okay, great. Thank you very much and have a great day ahead. All right. Thank you, Basraz. I'm happy that you find it excellent. Have a great day ahead. Bye bye. Please feel free to write the review, give the feedback, and all right. Thank you very much and have a great day.